So in order to not be such a bastard for making you know all your algebra, we're going to take one step further. This equation right here. What can you conclude from it?
Doesn't have a lambda 2. That's the one.
Well, valiant effort. But that's one thing that helps to pick this equation as a starting point. Let's focus on this. Right?
You can determine the value of lambda with respect to y at least, without having to both lambdas.
All right. Well, what would it say? Tell you for lambda 1?
Lambda 1 would be -1.
Yeah. All right. All right. So you could get a solution from this. Lambda 1 is -4.
Right.
Or is that the only possibility? Because how do you arrive at lambda 1 being equal to -4? How do you get that?
Your y's cancel out.
What?
Your y's cancel out.
Okay.
So it means you're.
So yeah, what you're doing is you can divide both sides by y and get lambda 1 is -4. Unless, when is that not possible?
Yeah, 2 separate y's.
And y equals 0.
If y equals 0, then what?
Then lambda, then it's 0. The whole thing is 0.
Yeah, the equation is satisfied. So, this tells you either markers. Lambda 1 is -4, or y equals 0. My point is, you have to check both possibilities in case one of them leads you to a dead end. Later on, if you have situations involving these variables squared, be sure to check both square roots, positive and negative. So things like that, where certain possibilities are missed, or will cause you to not get this. So once you explore whatever paths work to get you to two possibilities for x, y, and z, which is really what you care about, and just plug those in here and see which one gives you the shortest distance and the largest, the longest. Questions about that one?
Never got this side of the board covered.
What? Okay. Means I can go to this side of the board. And
You plug those into G1 and G2?
no, once you get your solutions, or actually you just take X, Y, Z, but plug them in up here.
Plug them into that.
Yeah, because whatever you find will already satisfy these. G1, G2 will be 0.
Right.
Yeah.
So does your f of x, y, z, is that because of the area that you're finding? Or, well, not area, but is that because of the form? Or is,
Saying why are we plugging them into here?
No, why is it f of x, y, z? Like, that's not given, so is that from the?
Oh, it's from the fact that you're trying to
Yeah.
maximize, minimize distance.
Oh,
From the origin, yeah,
Okay,
yeah,
and
okay.
so that's your gradient, okay.
Yes. Alrighty. Okay, anything more on this one?
Just out of curiosity, you have X, Y, and Z. You're gonna have a total of 6. Would it just be the first combination with the second combination, or would it be any combination of those 6?
Oh, okay, but there's going to be one triplet XYZ that, so you're going to get an X1, Y1, Z1 that satisfies these equations, but you plug in together. And then a separate triplet, but you'll also plug in, you can't mix it or match among these.
Okay.
So what you'll do is, from these equations, you'll arrive at a certain value for one of the variables. You'll plug into one of the equations to get values for the other one, fixed values. So you'll only have 2 scenarios.
Okay.
Alright, going once. Really combines aspects of 1 and 2. We have four x y. Okay, and you want the absolute max min on this disk. Okay. Disk is the origin, radius 3. So, first step is find the critical points of F. So, just like in number 1, except if you find any that are outside the disk, so x squared plus y squared is greater than 9, you ignore them. So, the disk, this part handles the interior only.
So you can't run out of marker.
Yeah. Then you consider the boundary. So this is more like the second problem. You use a method of Lagrange multipliers, and your constraint is that you're limiting yourself to the circle. So this is your constraint, x squared plus y squared minus 9 equals 0. So, a little simpler in that case, because you only have one Lagrange multiplier, so you're going to have 3 equations. You're going to have 2 equations coming from this, and then the constraint. So you define x, y, and lambda that satisfy these 3 equations. And then, whatever critical points you get from these 2 steps, you plug all of these into this function and see which is the largest, which is the smallest. And those are your absolute max and min.